Okay, welcome back to Calculus 2. We are looking at a problem for this one. It says the clotting time of blood is a random variable t with values from 1 second to 20 seconds. That's important. And probability density function defined by B of t, blood, is equal to 1 over t times natural log 20. Okay, and we have to determine the different probabilities here. Okay, so we're just going to set this thing up. Do we have to set up that it's equal, that it is a probability distribution? No, we do not. So what we're going to do is what is the probability that clotting time is between 1 and 5 seconds? So we're just going to go with integral between 1 and 5. There we go. 1 over natural log of 20 times t dt. And that's what we're going to figure out, just this integral. Fortunately, natural log 20 is a constant. So we're going to say this is 1 over ln 20 integral from 1 to 5 of 1 over t dt. That's not too bad. So this is going to be 1 over ln 20 times ln of t going from 1 to 5, and then we'll just figure this thing out. So we have natural log of 5 minus natural log of 1. This is all over natural log of 20. When you type natural log of 1 into your calculator, I hope you didn't have to, but natural log of 1 is 0. So we end up with natural log of 5 over the natural log of 20. I'm sure that's a delightful number. And as a matter of fact, I got it right here for us to check it out. So if we look at Desmos, natural log of 5 over natural log of 20, we ended up with 0.53. Okay. When you're dealing with probabilities, you should make sure that the number you come up with is a number between 0 and 1. Okay, always. Okay, it cannot be negative. It must be between 0 and 1. Okay. So that's what we're working on for that one. Okay. Problem number 2, what is the probability that it is greater than 10 seconds? Okay. So we want to know probability that t is greater than 10. Well, this probability function is only defined between 1 and 20. So greater than 10 can't be 1,000. It's got to be 1 and 20. So we're going to go between 10 and 20. Otherwise, we would have to set up an improper integral and then figure it out that way. But since we are constrained, it says so in the problem, that it can't go above 20 seconds. Like it's only defined between 1 and 20. That's the maximum we can go. So this is going to be 1 over the natural log of 20 times 1 over t dt. So this is pretty nice to figure out. This is 1 over 20 times integral between 10 and 20 of 1 over t dt. Again, that's a very straightforward integral, which is nice for a change. Natural log of 20 times the natural log of t going from 10 to 20. Go ahead and plug that in. We have 1 over ln of 20 times we have natural log of 20 minus the natural log of 10. I'm going to go through and distribute this thing. So we have natural log of 20 over natural log of 20 minus natural log of 10 over natural log of 20. Natural log of 20 over natural log of 20 is a fancy way to write 1 minus natural log of 10 over natural log of 20. That would be my answer. And again, we could double check it. We plug that into a calculator. That'd be great. But if we go through Desmos, we could see 1 minus natural log of 10 over natural log of 20 is in fact some kind of a fraction. I'm pretty happy about that. And that's where we're going to go. Okay, so that's how you do that part of the problem. Okay. Number 3, what is the expected time for blood to clot? Now, expected is a definite, there's a definition in math for expected. And expected value, the E of t, that's the expected value of t, is equal to t times the integral of f. Well, no, not that way. Got to go inside the integral. So it's the integral of t times f of t. So we're going to say integral of t times f of t dt. Okay, negative infinity to positive infinity. So normally we would have an improper integral here, but where is our probability distribution defined? Between 1 and 20. So this is going to be integral 1 to 20 of t times 1 over the natural log of 20 times 1 over t dt. And then, oh, those cancel. It's almost like I got this out of a textbook somewhere. So those are nice. So all we have to do is we have to integrate 1 over natural log 20, the integral from 1 to 20 of dt. That's a physics integral if I ever saw one. So we have 1 over natural log of 20 t, and then we're going to go from 1 to 20. So we end up with 20 minus 1 all over natural log of 20. We would go ahead and report that out. Expected value is the average. This is like your blood should start clotting in this many seconds. All right. So it doesn't have to be between 0 and 1. It could be whatever it wanted to. If I said, what is the expected number of like tires on your car? Hopefully that answer is 4, maybe a little bit higher than 4 if you got a spare. So it's okay for it to be above 0 there, or above 0.1. So we have 19, 20 minus 1 over the natural log of 20, and we are getting an answer of about 6.3 seconds for your blood to start clotting. Okay. So that's how you do that kind of a problem. I don't want you to be afraid of probability. They're really not too bad. Actually, they're sometimes the nicest problems that you're going to see on the exams, because they're usually a real world application to it, but it's just expected value is just the integral of x times f of x. And that's pretty much all there is to it. Okay. I'm going to say thank you very much for watching the video. Good luck practicing, and I'll see you in the next one. Okay. Take care.